A coronal mass ejection begins with magnetic field lines tangled beneath the solar photosphere at temperatures exceeding 15 million Kelvin. Plasma circulates along these field lines, trapped by magnetic pressure. Over hours or days, field lines twist tighter. The magnetic energy density increases. At some point, there is no prediction for when, the field reaches an unstable configuration. The instability triggers magnetic reconnection. Tangled field lines snap apart and reform into simpler configurations. When that happens, the magnetic pressure holding the plasma relaxes catastrophically. 1 billion tons of plasma, the mass of a small mountain, accelerates outward at speeds reaching 3,000 kilometers per second. The transition from trapped to escaping takes minutes. Once reconnection begins, nothing stops it. The ejected plasma expands as it travels outward through the corona. The magnetic field lines that were reconnected still thread through the ejecta, creating a coherent structure. This structure, the CME itself, travels through the solar wind at speeds that can exceed the ambient wind speed by a factor of 5. Solar wind density is nearly zero at these distances, so the ejecta expands unimpeded. Pressure drops as volume increases. If Earth is in the path, the CME arrives 30 to 60 hours later. The plasma arrives first, expanding into Earth's magnetosphere at 500 to 2,000 kilometers per second. Earth's magnetic field is compressed on the sunward side. Geomagnetic storms begin. The ejecta continues expanding for 3 to 5 days. The magnetic field embedded in the ejecta either aligns with Earth's field, producing minimal effect, or opposes it, triggering the most intense space weather events. The outcome depends entirely on the angle of approach. We cannot change it,